right, I think I got this thing in pretty good shape here. Most of my head in there, huh? All right, so there are the answers to the warm-up questions. And what we're going to do here today is nothing really new. It's pretty stuff that you've done before. So if I gave you this equation, 1/4 over 2/5, okay, it's a fraction over a fraction. But every fraction is a division problem. So all we can do with this is just simply rewrite it as 1/4 divided by 2/5. And do we ever divide fractions? No, we never divide fractions. I can't make me, won't do it. What do we do instead? We multiply by the reciprocal. So we're just going to take this, turn it over. The nice thing here is we've got a little bit of reducing that we can do. Make this a 2, make this a 1, and I end up with 1/10. So this is going to be equal to 1/10 right there. Okay? All right. So let's take a look in the book because it's going to be doing basically the exact same thing here. We're still recording. Good. All right. If you look at example A on page 609, because this is lesson 92. Okay, you see the first example they give you is A over X on the top of B, A plus X. All right, once again, it's just a division problem. So we can write this as A over X divided by B over A plus X. Okay? Now again, do we ever divide fractions? Nope, never going to do it. So we get A over X times A plus X over B. Now when I multiply this out, I'm going to get BX. Now here, the way the book, you'll notice, does it is they do A times A plus X. If you put A squared plus AX, I get it. Okay, I probably won't mark it wrong, but this is the way that they do these. So this is the way we're going to try and do these for now. All right, I'm going to give you another problem here. Okay, you got that one up there. Try and follow the same pattern. I'm going to give you B over Y plus A plus Y. Okay, again, the beauty of algebra, you don't have to know your times tables. There are no numbers. Okay, just go ahead and put that in, stop it, solve it, and then I'll show you what it should look like. Okay? All right, so here we go. We should get B over Y is divided by Y over A plus Y. And you might get really excited here, but you can't do that because we never divide, we multiply by the reciprocal. So we're going to get A plus Y over Y, multiply. And down here we're going to get Y squared. And on top, again, the way the book always has you do it is this way. B times A plus Y. Again, if you put AB plus BY, I get it, but that's not the way that they have us doing it. So anyways, pretty simple right there, okay? You got all the answers. Again, no numbers. Makes life easy. All right, let's move on. Let's go to example number 2 there in the book. Okay, and this is on page 610. We have AM over N. All of this X over MN. And we don't really do this any different. We're going to get, it's still just a division problem. So we write it as AM over N divided by X over MN. Again, I'm not dividing fractions. Not going to do it. Multiplied by MN over X. Now, what's different this time is... what's different this time is we get to actually do some reducing here. Make our life just a little bit easier. Do you see the reducing? You should, because this n becomes a 1 and this n becomes a 1. So that's less multiplication we have. What we're going to get over here is x, just good old-fashioned x, and on top we're going to get m squared a. Okay? Now they put it as a squared m, but you know, I like to do this with the higher number there first. So again, if you have it either way, you'll be good. All right, let me give you another one, okay? Here we go again. I'm going to leave that one up there. Let's see if we can do this. BT over AS all over R over ST. Okay, so take that one there, stop the video, solve it, and then let's see if you've got that one right. This is your one to try first. All right, here we go. So, again, we write it as a division problem. BT over AS divided by R over ST. But we never divide fractions. We get BT over AS times ST over R. Okay, now, see any reducing there? Yep. That S and that S cancel each other out. Okay, so down here in the bottom, we get A times R. Here on the top, we're going to get, I still like it better this way. I know it's not alphabetical, but the higher number right there, that's the way it should be. If you put those backwards and put BT squared, I'm not going to mark that wrong, okay? But just be aware that that's what it's going to be right there. All right, good with that? That is example number 2. Okay, just looking for some cross-reducing like we did before with our other equation. All right, time to move on. Let's go to example number 3 here in the book. This is on the bottom of page 610. Okay, 3x over 6x plus 12. All of this is over 9 over x plus 2. Okay? Now, once again, we just write it out as a division problem. 3x, 6x plus 12 divided by 9 over x plus 2. Okay? Now, again, we're going to multiply by the reciprocal. 3x plus 12 times x plus 2 over 9. Now, you got to be careful here. You might want to jump into this and go, oh, I can do some reducing here and here, but because you're adding, you can't do that reducing. Okay, these two cannot be reduced because you are adding right there. Okay, what you can reduce is this, because this is all multiplication. So this goes away, and this becomes a 3. Now, what we can do out of this is do some factoring. What can you factor out of this? Yes, you can factor a 6. So you get 6 times x plus 2. Oh, how nice does that look? Okay, now I can factor out this, and I am left with x from here, and then down here I am left with 6 times 3, so I should have x over 18. Isn't that what it says in there? It sure does, okay? So there's a really good example there. Let's try one on our own. All right, how about this one? X squared minus x over 9, and put that whole thing over x minus 1 over 3x. So go ahead, try that one, okay? Stop the video, and then see if you can get that one correct. All right, so here's what it should look like. We have x squared minus x over 9 divided by x minus 1 over 3x. Only we're not going to divide, we're going to multiply by the reciprocal. So this stays the same, but this side over here becomes 3x over x minus 1. Okay, well, let's see. Is there any reducing we can do here? Hey, we can do this. That 3 goes away, and that 9 becomes a 3. And over here, what can we do with this? Well, when we factor this out, we are going to get x minus 1 and x plus 1, right? No, that's not right. We factor the x out of there. We get x minus 1. There we go. Okay, so we got that. Now, see any more reducing? Oh yeah. This goes away, and on top we are left with x times x is x squared, and down here we get just good old-fashioned 3, and I know it's a different color there, but it's x squared over 3 if you got that one correct. Okay, so that is example number 3. All right, let's go to example number 4. Here we go. All right, example number 4 says